When you add polynomials, you combine like terms. Every time I do it, it makes me want to squirm. When you get to subtracting, it's all the same. But when it comes to multiplying, it's a whole different game. Distributive property is what you do. It's just as easy as taking a poo. When it's two binomials, you just FOIL. It takes less time than water to boil. Word.
I'm going to show you how to add polynomials. You have to add the like terms. First, you add 3 and 7 equals 10x squared. And then you add negative 5 and negative 3 equals 8. And that's all you have to do. That's your final answer. This is example 2 of adding polynomials. First, you're going to add x squared and 5x squared and get 6x squared. Then you're going to add 5x and negative 11x and get negative 6x. Then you add negative 7 and negative 6 and get negative 13. And that's your final answer.
I am here to teach you how to subtract polynomials. First, you take x squared and subtract negative 4x squared. You get 5x squared. Then you take negative 3x and minus 8x. You get negative 11x. Plus, you take 5 and minus 9. You get negative 4. And that is your answer. This is example 2 of subtracting polynomials. First, you take 4y squared and minus 4y squared. Those cancel out. Then you take 9y and subtract negative 5y. You get 14y. Then you take negative 5 and subtract 3. You get negative 8. And that is your... I'm here to teach you how to multiply polynomials. Since it's just two binomials, all you have to do is FOIL it, which would be 3x times x, which would give you 3x squared, and then 3x times negative 3, which would be negative 9x. Then 1 times x will just give you a positive x, and 1 times negative 3, which will give you negative 3. Then you combine like terms in the middle, which you get a negative 8x. So the 3x squared minus 8x minus 3. This is example 2 of multiplying polynomials. For this one, you would just do distributive property. 5x squared times 6x is 30x to the third, and 5x squared times 2 is 10x squared. And that's the answer.
We're going to try and find the area of our living room. So we're going to draw the box, and it's broken up into 2 sections. One section is x plus 3, and the other is x plus 9. And the other side of it is x plus 5. And then to find the total length of that combined, you have to add these two. So x plus x is 2x, and then 3 plus 9 is 12. Then you have to FOIL 2x plus 12 and x plus 5. So 2x times x is 2x squared. And then 2x times 5 is 10x. 12 times x is 12x. And 12 times 5 is 60. And then combine like terms in the middle, you get 2x squared plus 22x plus 60. And that is your answer of the answer.
Polynomials!
Oh my god!
Oh yeah, we will, dog. Yo, I got you, man.
Okay, so I'm going to help you find an equation that'll help you find the inside value of this square. We know that the bottom is divided up into two sections, x plus 9 and x plus 3. And the side is x plus 5. So we're going to start out by adding these terms right here so that we can find the overall length of the bottom. So we're going to do x plus x, which is 2x, and then 9 plus 3, which is 12. Okay, that's going to be the first part of our equation. Then we're just going to bring down the x plus 5. Now we're going to simplify this even more. We're going to start out with 2x times x, which is 2x squared, or 2x squared, okay? And then we're going to do 2x times 5, which is 10x, okay? And then we're going to FOIL on to this part, so it would be 12 times x, which is 12x, and then 12 times 5, which is 60. So this is our equation that we got out of this, and all we have to do now is add the like terms. So we have 2x squared, and nothing else on here is x squared, so it's already simplified to its form, or there's no forms that are like to add to it. So that's just going to stay the same. But right here we have 10x and 12x. We're going to add those together because they both have x's. So that's going to be 22x. Then we're just going to do plus 60 because 60 is alone and there's no other like terms. So this part right here would be your equation that'll help you find the inside of this square.